Welcome to the video on states of matter. Matter has a mass and a volume. It is a physical substance that takes up space. Matter can be divided into two categories: mixtures and pure substances. A mixture is created when two or more different substances are physically combined and can be separated back into its original substances. Examples of mixtures are a bowl of different kinds of candy, a pile of different kinds of leaves, steel, syrup, and ice cream. There are two different types of mixtures as well. One is considered heterogeneous, which means that it's different throughout. It could be a bowl of different kinds of candy or chocolate chip cookie dough ice cream. The second is homogeneous or homogeneous, and homogeneous mixtures look like one component. They're mixed together so smoothly that they're uniform. For example, steel is made from iron and carbon, also vanilla ice cream. It's the same throughout. And within the homogeneous mixtures, we have two types. One is a solution, where we have aqueous as the base, and we have compounds that are dissolved in the water, and so it looks uniform, and it is uniform. The second is called a suspension, and this is where we have a solid that is in the liquid and it stays a solid, but it's evenly distributed throughout. So you have a solution that has even very small solid particles, but it's even and it's uniform throughout the sample. And so that would make it a homogeneous mixture that is a suspension. And our other example of matter is a pure substance. A pure substance is a particular kind of matter with uniform properties. And pure substances can also be broken into two categories: elements, so specifically off of the periodic table, things that exist as elements, and these contain only one type of atom, and they're right off the periodic table. The other type is called a compound, and these are when we have covalent bonds in molecules that contain atoms that are different from each other. So this is a substance containing different elements chemically bonded together. We look at the definition of matter, we ask ourselves, can this material be separated into more than one substance using only physical methods? In other words, we don't break any bonds. If the answer is yes, then that means we have a mixture. If the answer is no, then that means we have a substance. And recall that mixtures can be separated into substances by physical methods. And then if we have a mixture, in order to determine whether it's heterogeneous or homogeneous, we ask, are the different parts distinguishable? And if we have a substance and we are trying to decide whether or not it is an element or a compound, we ask, can the material be separated into similar substances using chemical methods? If the answer is no, then we know that that is an element. If the answer is yes, then that means we have a compound. So remember, a compound is a substance that contains different elements chemically bonded. And an element is a substance that contains only one type of atom right from the periodic table. Some terms that I've been talking about throughout the whole course: atoms are things directly off the periodic table. Elements are the natural form that the things on the periodic table take in nature. So, for example, manganese and helium exist as a single atom, whereas oxygen and hydrogen are both diatomic atoms, so they exist as a pair. So the single oxygen atom would be an atom. When two are bound together, then that's going to become an element. And actually, it's also considered a molecule. A molecule is when you have a chemical bond between two atoms. And to be more specific, if you had a compound versus a molecule is anything that is bonded together, and a compound is when you have two different atoms bonded together. So I stated that if it's a mixture, we can separate it by physical means. One way is through filtration, so we can let the liquid flow through and collect the solid using a filter paper. Distillation is a technique that we can use where we can separate a mixture based on boiling point. So if you have a mixture of two liquids and one boils at a different temperature than the other, we can remove the one that boils at a lower temperature and leave the one that boils at a higher temperature. And finally, we can do crystallization. And crystallization is a way that we can make things soluble or insoluble, and we can use that to separate. So those are three examples of physical methods that we can use to separate mixtures. So here's some practice examples of deciding whether things are pure substances or mixtures. Concrete is a mixture. And if we look at that as a mixture, we have to decide whether it's homogeneous or heterogeneous. And it turns out that it's heterogeneous because as you look at it, there's going to be different pieces and chunks and colors. And so it's not the same throughout. And that would be heterogeneous. Fe, iron filings, this is a pure substance and it is only one thing. So that's going to be termed an element right off the periodic table. Limestone is a pure substance, but if you look at that, you can see that it has different atoms chemically bonded. And so that's going to be a compound. And we'll do the rest of these in class. Now, if we talk about states of matter, meaning solids, liquids, and gases, solids are hard and they do not take the shape of their container. For example, your pencil is a solid. The atoms in your pencil, the atoms in a solid are held very, very close together and they're very organized, as you can see at the bottom with the blue solid structure. It's very organized. And the attractive forces between those atoms being held together is very strong. Next, we have liquid, and liquid atoms are also very close together, but they're more disordered than a solid, as you can see from the green balls rolling out of the beaker. And these atoms still have a pretty good intermolecular interaction or attractive forces between the atoms, but it's not quite as strong as the solid. Those atoms are going to be a little further away from each other than what was in the solid. Liquid takes the shape of its container as well. The last one we have is gas, and gas molecules are very far apart from each other. The attractive forces that they have is much, much less than a liquid. They're farther apart. They're spread way out. They take the shape of their container. And again, there's little attractive forces between those atoms. Phase changes, when we change from solid, liquids, and gases, those are physical changes. We're not breaking any chemical bonds here. We are just changing the physical state. And when we go from a solid to a liquid, that is considered melting. In melting, the atoms move a little bit farther away from each other. And when we go from a liquid back to a solid, that's called freezing. And freezing brings those particles closer together again. And when we have a gas that goes to a liquid, that is called condensation. You may think of that in a glass of ice water in the summer where beads of water form on the outside of the glass. So that's the water vapor from the air condensing on the outside of your glass. And in this case, the atoms return to the liquid state. And when we have a liquid going to a gas, this is called evaporation. This happens in a mud puddle, right? When the sun shines on the mud puddle, and then the mud puddle goes away, and then we have all that water that evaporated into the air. I also think of boiling in this case. It's a faster way to make a liquid go to a gas. Now, if we want to take the solid directly to the gas and we just skip the liquid, that's called sublimation. And if we have a gas and we take it directly to the solid, skipping the liquid again, that's called deposition. So if I look at the three phases of matter in this way, when we go from a solid to a liquid, that's called melting. And when we go from a liquid to a gas, that's called evaporation. And then when we go from a gas to a liquid, that's called condensation. And when we go from a liquid to a solid, that's called freezing. And then when we go from a solid directly to a gas, that is called sublimation. And when we go from a gas all the way to a solid directly, skipping the liquid, that is called deposition. So when we take a solid and put it towards a liquid and or towards the gas, this process right here, we have to put heat in. If you can think about taking a solid to a liquid, we have to melt it. We want to put that ice cube in our hand and warm it up, add heat from our body to make it a liquid. And also, if we want that liquid to go to gas, we need the sun to shine on that mud puddle. Put heat or energy in. And alternatively, when we go from a gas to a liquid and or straight to a solid, right? As we move in the down direction here, energy is given off. I just want to draw your attention to a couple different types of solids that we have. We have crystals and we have glass and we have polymers and liquid crystals and oobleck. So these are all where the molecules are packed very, very tight together. Here's a quick schematic showing you the difference between a solid, a liquid crystal, and a liquid. And it's all about the order in that case. Okay, there you have it. States of matter.